Welcome to Ask and Learn.
For problem 15.190, we know that the simulator rotates about the planetary axis with an angular velocity of 20 revolutions per minute in a counterclockwise fashion if we see it from above. And we need to calculate the angular acceleration of the cab of the simulator with respect to a fixed frame. If we know that the constant pitch angular velocity is 3 radians per second counterclockwise if we see it from the positive z-axis. And the other case, if we know that the cab has a constant roll angular velocity of 4 radians per second clockwise, in a clockwise fashion if we see it from the positive x-axis. Before we begin, let's convert revolutions per minute to radians per second. As usual, we can do this by multiplying by 2 pi, because one revolution equals to a 2 pi angle, and divide by 60. And this gives us approximately 2.0944 radians per second. Okay. Next, we have to choose the rotating frame in order to apply this very convenient equation by which we can express the angular velocity, the angular acceleration, of an object with respect to a rotating frame. Let's call the rotating frame. Let's denote it with prime indices. This capital omega is the angular velocity of the rotating frame, and this is the angular velocity of the cab with respect to the rotating frame. Okay, so for convenience, we can choose immediately a rotating frame which rotates with the simulator about the planetary axis with exactly the same angular velocity. So omega capital is just a omega simulator. And we have to specify the direction of this vector. We only from here we only know its magnitude, and from the drawing we can see that this is parallel to the y-axis. So let's express it like this, radians per second. And now an observer on the rotating frame, we see that the cab has only the corresponding angular velocity for each of the two cases above. So the angular velocity of the cab will be just the omega cab from above. An observer on this rotating frame won't notice at all any acceleration, angular acceleration, any rate of change of the angular velocity. So we have established that in order for both tasks, we only have to do the following calculation. So let's do it for both cases. Case A, angular acceleration times 3k hat. And I hope it is obvious that this gives immediately about 6.28 I hat radians per second for task B. Minus for I giving us approximately 8.38 k hat radians per second. And this is it.